Okay, Algebra 2, today's lesson is going to be graphing piecewise functions. These are the notes as the introduction to this. So if you look at some of the vocabulary here, you're used to seeing a linear function in xy notation. That's y equals mx plus b. That's your slope-intercept form. We're now introducing a linear function in what's called function notation. F of x equals mx plus b. So instead of y, we have an f of x. Function notation uses f of x, g of x, h of x, or some other letter to name a function. So a couple key points here at the bottom. You pronounce this as f of x, or g of x, or h of x. And essentially it just means the same thing as y. F of x and y are the same thing. So if you see f of 2, normally this says f of x, so if you see f of 2, that just means we are putting 2 in place of x. So you're plugging in 2 for x. So for example, if f of 2 equals 5, that means you plugged in x is 2, and then since this whole thing equals y, then you have the point 2, 5 is your xy. And you'll see more how that works. So this is just a general picture. This is a piecewise function. It's graphs of lines or absolute values or quadratics or any type of function, but in bits and pieces. So that's what we're going to be leading up to, so you just see where we're headed. So what we're going to do first is just work with this function notation. So first we're going to decide, can we tell if this is linear, which is a line, and then we're going to find f of negative 3. So number one, is this linear? Well, a linear function is going to be f of x equals mx plus b. So this is not linear because of the x cubed. So we're going to say that this is not linear. But we can still find f of negative 3. So that just means that x is negative 3. Plug in negative 3 for x. So this is going to be negative 2. And we're going to plug in negative 3 for x. So negative 3 to the third power plus 5. So negative 3 to the third power. What does that mean? It means negative 3 times negative 3 times negative 3, or negative 27. So this is negative 2 times negative 27. Plus 5. Simplify this. 2 times 27 is 54. Negative times a negative is a positive. 54 plus 5, 59. So f of negative 3 equals 59. Number 2, is that linear? So even though the mx and the b are written backwards, this is still a linear function. So yes, this is linear. So now if we want to find f of negative 3, we're going to plug in negative 3 for x. So we have 12 minus 8 times negative 3. Order of operation says we're going to multiply these two first, and we get negative 24. So f of negative 3 is going to be 12 minus negative 24. Minus minus means plus, so this is 12 plus 24. Which is 36. So f of negative 3 equals 36. From the last slide, we had talked about what point did you find for these functions. F of negative 3 equals 59. And since we know that f of negative 3 means x equals negative 3, and f of x, f of anything, is the same as y, then f of negative 3 equals 59 is the point negative 3, there's your x, 59, there's your y. So what point do we have here on number 2? Well, this is negative 3, 36. So this is what a piecewise function looks like. All this means is those are those different pieces with different restrictions on x. Okay? So right now we're just going to evaluate. So f of 0, what does that mean? That means x equals 0. Well, if we look here, which of these is x equal to 0? This first one is x is less than 4. Here it's between 4 and 9, including 4 and including 9. And here is strictly greater than 9. So which of these is where x equals 0 falls? Well, right here. This is where x equals 0 falls in that category. Okay, so at x is 0, we have the function x minus 1. So f of 0 is going to be x minus 1, or 0 minus 1, or negative 1. So we just found that f of 0 is negative 1. Number 4, how about f of 6? 6, where is 6 going to fall? Well, 6 is going to fall between 4 and 9. So in this line is where x equals 6. Okay, so at x equals 6, f of x is going to be x, which is right here. Okay, so f of 6 is going to be 6. F of x equals x. So the point we just found is f of 6, there's our x, equals 6. That's our y. So we can go down here and start doing our points. This was the point 0, negative 1, and this was the point 6, 6. F of 10, where does f of 10 fall? Well, 10 falls here. 10 is greater than 9, so x equals 10 falls here. And at all values greater than 9, f of x equals what? F of x equals 2. So f of 10 equals 2. F of 11 equals 2. F of 100 equals 2. At all values bigger than 9, f of x will equal 2. So f of x equals 2, so that's the point 10, 2. Now we have f of 9. F of 9 is a little bit more challenging because we need to know exactly where that falls. So we need to know our symbols. This is x is less than or equal to 9, and this is x is greater than 9. We want exactly 9, so that's going to fall here, where x is less than or equal to 9. And at that point, f of x equals x. So f of 9 equals 9, which is the point 9, 9. Okay, so that's evaluating, and that's what we'll be hitting today before we start graphing these piecewise functions. Also, one thing we want to review is just simply graphing lines. So, looking at a function, all this means is y equals mx plus b. So your m is negative 4, and your b is negative 1. We plot our b first, we go down 1 and put a dot, and then our slope is negative 4. Okay, so negative 4 is going this direction. It's a downward slope. So we can either go down 4 over 1, or we can go up 4 and left 1. Either way, that gives us our downward slope. That's not a very good line. Should hit that point. And number 8, how do you graph this line again? F of x just means y, so y equals negative 2. You should remember that y equals a number is a horizontal line. Horizontal line at negative 2 right here, so there's our line. Okay, here are your video examples. Take the time, pause now, go through these examples, and we will go over them in class tomorrow. Have a great night.